Let's continue our study of hyperbolas and take things a little bit further today. We're going to look more at those asymptotes of the hyperbolas. But let's just get started. We've got an equation, x plus 3 quantity squared over 144 minus y minus 2 quantity squared over 25 equals 1. So just looking at the equation, we can make some determinations. First of all, we got a minus sign here, so that tells us we have a hyperbola. We can also just read from the equation what the center of that hyperbola is. And the x-coordinate is opposite what you see here, so -3, +2. So we know the center. We also can determine, because the first term here is our x term, that tells me that my transverse axis is going to be going in the left-right direction. It's horizontal. It's not going to be on the x-axis because our center is shifted here, but it's going to be parallel to the x-axis. So my hyperbola is going to open right and it's going to open left. 144 is our a squared value. So a is the square root of that. Our a value is 12. So let's take that much and let's plot it on our graph here. So I should have written it in. Each block here is representing 2. So I'm going to go over -3, +2. I'm going to be here. That is the center. And I'm going to come to the right and to the left 12, because that's what my a value is. So let's go 2, 4, 6, 8, 10, 12 will put me right here. And I'm going to write the vertices over here. So my vertices, my vertex on the right here is -3 plus 12, in other words, +9. Same y value as the center, so 2. And then I'm going to move left from the center, 2, 4, 6, 8, 10, 12. And the coordinates there are -3 in the negative direction, 12, so we're at -15. And again, that y value is still 2. So here's my transverse axis. And remember, from the center to each vertex is our distance that we call a, and that is 12. Okay, both sides. All right, let's draw our asymptotes. And to do that, we need our guide box. So let's look at our b values. So b squared is 25, which means b is 5. So let's plot that here. We're going to come up and down from the center a distance of 5. So 2, 4, 5 is here. 2, 4, 2, 4, 5 puts me here. And I am going to try to sketch in that guide box. I hope you're doing the same with me here. Got kind of a large one for this problem. Okay, so it's something like this. So let's take a look at these 2 upper corner points. And let's just figure out the coordinates of those. Remember, the x-coordinate is going to be the same as the vertex. So we're at an x-coordinate of 9. and we came up a distance of 5, so we're at 9, 7. And our left upper corner, we came over 12 and up 5, so that puts us at negative 15, 7. And let me just try to sketch in these asymptotes. Again, it's kind of a big one here. Guide box here, so there are my asymptotes. And let's figure out what the slopes of those two lines would be. We know what slope is. Rise over run. So if we look at our positive slope here, you'll notice there's one asymptote has a positive slope, one has a negative. The rise, we came up 5 over 12, so that's the slope of one of the lines. The other, same idea, rise is 5, but we went to the left 12. So we have slopes that are opposites of each other. Positive 5/12 for this line, negative 5/12 for this line. So to write the equations for those, there's several different ways we could approach this. Let me talk about the one I prefer. Point slope form of the equation of the line. I don't know how much this is taught in our algebra classes. I know that when my boys took algebra at a different school, this was not emphasized, but it's, I think, the most convenient form in this situation because we know the slopes of these lines and we know a couple different points, but the most significant point on those asymptotes is the center. So we could just write the equation of this asymptote by plugging in the slope and plugging in the coordinates of the center. So we have y minus 2 equals 5/12, x minus negative 3, so that'd be x plus 3. And for our other asymptote, everything's the same except the slope is negative. And then sometimes you might see, like in the back of the book or something, they might want to have y isolated. So you'll see something like y equals plus or minus 5/12 times the x plus 3. And then we had to add 2 to both sides. So any of these forms works. Point slope form, you can kind of combine them. You know, if you're just going to show the general slopes of the line, you could combine them with this plus or minus. Now when you plug them into WebAssign, they're going to ask you to type in each equation for each asymptote. They're going to ask you for the one with the negative slope first, so make sure you're giving them what they're asking for, and then the positive slope below that. So this form works. I went on to WebAssign and I tried it. This form works. You could also do this form. Obviously you're not going to want plus and minus, you know, for one of the equations it'll be minus, for one of them it'll be plus. But you could type it in like this. I also just wanted to show you your more commonly used equation of a line is that slope-intercept form. And we could do that here as well because we know a point on the line, which is the center, and we know the slope. So let's do that because this is the one you're more familiar with. So the y coordinate is 2, slope is 5/12. X was -3. And then we don't know the y-intercept, but we can figure it out pretty quickly. So 3 goes into 12 4 times, so I've got 2 equals -5/4 plus b. And if I add 5/4 to both sides, I get b equals 13/4. So that gives me y equals 5/12x plus 13/4 for the equation of this asymptote that has the positive slope. And again, keep in mind each of my grid marks here is representing 2, so 4, 8, 12, that 13/4, that looks about right. And if I did the same process for the line here with the negative slope, I would get y equals -5/12x, and my intercept would be 3/4. Have I been writing and you guys can't see my writing? Oh well, sorry. I'm gonna go with it though. I'm not gonna start over. All right, so this equation is my positive slope, and this is what you get for the negative slope. So WebAssign will accept any of these forms. I checked it out. Just make sure you are giving them what they're asking for. You type in the one with the negative slope first, and then the positive slope. So we're done here, except we need to figure out the coordinates of our foci. And I have a mess, but for all hyperbolas, we have this relationship. C squared equals A squared plus B squared. C squared is A squared is 144. B squared is 25. That is 169. I recognize that as 13 squared, so C is 13. So for my foci, I'm going to start at the center, and I'm going to come over 13, and that's going to put me here. So I'm going to be at 10, 2, and then I'm going to move left 13, and that's going to put me at -16, 2. And keep in mind that that distance from the center to the foci, so this distance here is our C value, and in this case it's 13. So that pretty much completes our problem, but let's just now at least sketch in what the hyperbola looks like. Here's my vertex. It's going to open to the right, and it's going to open to the left, and we're done. All right, so that is sketching a hyperbola and finding the slopes of those asymptotes.